Hello and welcome to Worksheet 2A. This is for MAT122 or College Trig. Today we're going to be talking about all the topics on 2A, and this is going to include talking about radians to degrees and degrees to radians. We're going to be talking about circles once again, and talking about like sector length and then the area of a sector. So there are a couple notes before we get started on this worksheet, and I'll just put these here in the video that you'll want to be familiar with. The first one is the unit circle. I'm certain that you guys did this in Algebra 2. If you don't have a copy of the unit circle somewhere, you might want to write this down or just print off a copy of the unit circle, because this is going to become very, very valuable. We're going to be referencing it a lot, not just in this chapter, but the next couple chapters. So you have to be comfortable with the notion of degrees and then radians, how they're two different systems for measuring how big an angle is. Okay, so looking at the unit circle, we have pi divided by, well, let's start off real easy. The amount of degrees in a full rotation, or the full distance around a circle, is 360 degrees. If we're talking about radians, a full trip around a circle is 2 pi. So, we need to get comfortable with keeping that in mind as we do these problems. Okay, so the two conversions that we're going to need for these first couple problems are switching from radians to degrees, and then if we have degrees, switching to radians. So here are the two formulas you're going to use. They're pretty straightforward. They do involve pi, and I like to avoid multiplying by pi or dividing by pi until I have to. So if like a lot of times pi's will cancel off. Okay, so let's look at number 1 real quick. It says, find the degree measure for each angle and express your answer in exact form. So that means in terms of pi, and then the approximate form in degrees decimal. So for the first one, for number 1, we have 180 times pi, or 180 divided by pi times 2, because we have 2 radians. Well, exact form of this, and I don't have this written here, it's going to be 360 divided by pi. That's what they mean by exact form, because there's no rounding involved. I did 360 divided by pi in my calculator, and that's how I came up with the 114.59. They wanted us to round this to the hundredths, so that's point, number. So I don't remember what was after the 5, if it was an 8 or a 9. But that's what it ended up rounding to. So make sure when you're rounding, you're getting the exact same answer as me, okay? Let's look at number 5. Number 5 says we have 110 degrees. How much is that in radians? Well, if we got this in exact form, it would be 110 pi over 180. You could reduce that, divide both by 10, so it would be 11 pi over 18. If you do 11 pi over 18 and plug it into a calculator, you get 1.92, and that's in radians, so I wrote rad after that, okay? All right, so let's talk about the next section. We're talking about a circle with a radius of 7, and they're talking about arc length. We've talked about arc length before, but if you don't remember the formulas, we had a single formula last time because all we were talking about was degrees. So this time we're going to add a second formula, and this one's going to be as if they gave you the angle in radians. If they give it to you in radians, you could convert it into degrees and use the same formula we were using, but now we have a new formula which just puts it in radians, so it's a bit easier. Okay, so we're still going to find the circumference. We're going to plug it into this formula for the arc length. So let's look at number 7. So number 7, they said, find the arc length if the central angle is 1.35 radians. So first thing I did was I found the total circumference for this circle that they're using for 7, 8, and 9. By plugging 7 in for the radius, doubling it, and then multiplying it by pi, you get 14 pi. Now that 14 pi will go in for your circumference on this formula. Once again, I'm using the radian version of this formula. And so you get 1.35 divided by 2 pi. and that's the fraction portion. And then just multiply that times the circumference that we found. Well, the pi's will cancel off, and so it's just 14 times 1.35 divided by 2, and I got 9.45. I don't know if there's any decimal after that. I think that's it, so it shouldn't be squiggly lines. It should be just a normal equal sign, but 9.45 meters is what I got for an answer. Let's look at number 11. Now, for 10, 11, and 12, we're using the same circle for all three of them, and this time we're talking about the area of a sector. Well, area is like, how much area does your slice of pizza have? Okay, so we're going to talk about the area for the whole pizza, and then we cut off a slice. How much area is that slice? So the area formula is pi r squared. This is a radius of 12, and they give that to us. So we square the 12, we get 144 pi, and that's the area for numbers 10, 11, and 12. You're going to use the same area. And then we have a very similar equation for the area of a sector as is the arc length. And basically, we're going to take our area and multiply it by some fraction. So once again, we have our degrees formula and we have a radians formula. So I'm going to do number 11, and that one is in degrees. So that's the formula I'm going to use for it. So we take the area that we found, so the 144 pi, we stick that in. And then we have 25 degrees divided by a total of 360 degrees. If you multiply that out, you are going to get a big long decimal because it involves a pi. And you're going to get 31.42. The units on that are centimeters because that's what my radius was in centimeters. But these centimeters are being squared because it's an area. So don't forget that centimeters squared at the end. Okay, number 13. Number 13, we have a particular man, while standing facing forward, can swing his leg through the air at an angle of 2 pi over 3. So pretty high kick. Find the length of his kick. So the arc length is what we're looking for as his heel traces out as it completes one swing. The length of his leg is 102 centimeters. Okay, so there's a bunch of extra information in there that we don't really need, but let's start with circumference. So we plug that into here. We know the radius is 102 because that's how long his leg is. So we double that, we get 204 pi, and that's the total circumference. So we plug that into our formula, and now we have to remember they gave us the angle in radians, so that's the formula we have to use. So 2 pi divided by 3, all of that dividing by 2 pi. Some pi's will cancel off here, but as long as you plug it into the calculator correctly, you'll get the right answer. I got an arc length of 2,108.43 centimeters. So that is what you get. Okay, let's look, and this will be the last problem we'll do. Let's look at number 15. So it says, figure out the side length of an equilateral triangle. So all the sides are the same. Or the side length of this triangle is 20. So we have equilateral triangle, all sides are 20. So that's what I've drawn here. And it also says the altitude or the height of this triangle is what we're looking for. So I have 20 on the sides. That bottom edge I cut in half because the altitude is cutting it in half. And what you notice here, or you might notice, is that we have a 30, 60, 90 triangle. All the angles in an equilateral triangle are 60 because it's 180 divided by 3. And then that top angle is getting cut in half, so 60 cut in half is 30. So we end up getting a 30, 60, 90 triangle. Well, we talked about the special relationships that you have with a 30, 60, 90 triangle. If we look at the shorter leg, we double it to get the hypotenuse, and that's exactly what we have. We have a shorter length of 10, we double that, we get 20. And then to go the other way, we take the shorter leg and we multiply it times the square root of 3. Well, 10 times square root of 3 is just 10 root 3, and that is our final answer for that one. Okay, number 16 deals with a 45, 45, 90 triangle, so don't forget that relationship, but that is a bit of review from the last chapter. Okay, please look at my answer keys online. If you should have any questions or not sure what I did or whatever, feel free to email me or just ask me in class when you see me, and that should be good. All right, that is it for me. Have a lovely day, and once again, this is Worksheet 2A, all right?